All right, today we're pulling back the curtain on a process that happens thousands of times a day in medical labs all over the world. We're going to go on a little invisible investigation to figure out what is really going on after a doctor takes a sample from you. So let's just dive right in.
You've totally been there, right? You've got that awful sore throat, you head to the doctor, and then you get that familiar tickle of a cotton swab at the back of your throat. But then what? The swab just vanishes into a little tube and gets whisked away? Well, today, we're following that exact swab into the lab to uncover the really cool science they use to find the culprit behind your cough. So here's the massive challenge for any lab technician. Your throat is home to literally millions of microorganisms. Most of them totally harmless, but hidden somewhere in that crowd could be the one type of bacteria that's causing all the trouble. So how do you find one specific troublemaker in a crowd of millions, especially when they're all completely invisible? Well, you've got to make them show themselves.
And the main tool for this whole investigation is something called a culture medium. Honestly, the best way to think about it is like an all-you-can-eat buffet, but made just for microbes. It's packed with all the good stuff they need to grow and multiply. Things like carbon, nitrogen, minerals, until they form a big enough clump that you can actually see. And that clump, that's called a colony.
But, just like any good buffet, this one comes in a few different styles, and each one has a very specific job in our investigation. The first big decision a scientist has to make is about the physical state of the medium.
So you've got two main options here. First, there's the liquid media, or broth. Think of it like a nutrient-packed soup. It's fantastic if all you want to do is grow a huge amount of bacteria really fast. But if you need to separate the good guys from the bad guys, you really need a solid surface. And that's where solid media comes in. It has the consistency of a firm jelly, and it is absolutely crucial for isolating the culprit.
And that kind of brings up a great question, right? How do you get this nutrient soup to turn into a stable, solid jelly that bacteria can grow on, but not, eat right through? The answer is this really remarkable substance.
Okay, so the secret ingredient is agar. It's a complex sugar that comes from red algae, and it has these almost magical properties. You can sterilize it at a super high temperature, but it only solidifies at a temperature that's cool enough not to kill the bacteria. And here's the most important part. Bacteria can't digest it, so it becomes the perfect, stable stage for microbes to grow on. It's like an edible plate that nobody actually eats.
So we've got our solid stage, but a simple buffet just isn't going to cut it for our investigation. To find one specific culprit in a huge mixed-up sample, scientists have to get really clever. They have to start designing a very specific menu.
Let's circle back to our main problem. That throat swab is a microbial metropolis. It's a jungle in there. If you just grow everything on a standard plate, you're going to end up with a chaotic mess. The solution is to create media that act like real tools of detection, specifically designed to help one type of microbe grow while stopping others.
The first tool is called selective media. I want you to think of it like a nightclub with a really strict bouncer and a VIP list. This stuff has ingredients, maybe certain salts or dyes, that act like a barrier, stopping most bacteria from ever growing. Only a select few, the ones on the VIP list, can get past the bouncer and start to thrive. A classic example of this is macaconchie agar, which is famous for letting certain bacteria grow while shutting down others completely. Now the second tool's even more clever. It's called differential media. This isn't about blocking anyone at the door. Oh no. This is about making them reveal their true identity. This magic plate has special indicators inside that react to what the bacteria are doing, their metabolism, their actions. So based on how they interact with the ingredients, different bacteria will turn different colors or create these unique patterns, which makes them super easy to tell apart.
So you see, scientists use these media together almost like a detective's toolkit. They might start with a general, all-purpose medium to get everything to grow. Then they'll use a selective medium to filter out all the irrelevant stuff. And finally, they'll use a differential medium, like the blood agar we're about to talk about, to make the main suspects reveal themselves with these really cool visual clues.
Okay, we've got the theory, we've got the tools. Now let's head to the crime scene and see how this all comes together. It is time to solve the mystery of the sore throat.
So back in the lab, the technician takes our throat swab and gently streaks it across the surface of a blood agar plate. Now this plate is both a complex medium, it's super rich in nutrients from the blood, and it's a differential medium. And it's right here that the bacteria are going to leave behind their fingerprints. And here it is. This is the aha moment. As the bacteria grow, some of them release these toxins that actually destroy the red blood cells in the agar. Scientists call this hemolysis, and it shows up in 3 distinct ways. Gamma means nothing happens. Alpha is a partial breakdown, and it looks kind of greenish. But beta hemolysis, that is a complete clear zone around the colony where the red blood cells are just gone. That is the smoking gun. It's a huge clue that the culprit might be Streptococcus pyogenes, the exact bacteria that causes strep throat.
Seeing that clear zone on the plate, well, that's the result of an incredible amount of careful, precise work that all happens behind the scenes. Getting that result depends on absolutely flawless preparation.
Yeah, this whole process is built on flawless prep. Making a culture medium is like following a super precise recipe where every single step is critical. Everything has to be perfectly measured and then sterilized in an autoclave, which is basically a scientific pressure cooker to kill off any stray contaminants. One little mistake could compromise the entire investigation.
And to actually isolate the culprit from that huge crowd, technicians use this really elegant technique called the streak plate method. By spreading the sample and then systematically thinning it out across the plate, they dilute it so much that individual bacterial cells get left all by themselves. Each of those single cells then grows into its own pure, separate colony, all ready for a positive ID.
So, let's just sum it all up real quick. Culture media are the essential buffet that makes invisible microbes visible. Agar is that magic, indigestible jelly that gives them a stage to perform on. And those specialized media, the selective and differential ones, they act as a detective's most important tools. By looking for those visual clues, like the breakdown of blood on an agar plate, scientists can crack the case and tell your doctor exactly what's making you sick.
This whole intricate process is designed just to find one type of bacteria in a single sample. It kind of makes you wonder, doesn't it? If this is the kind of care and ingenuity it takes to explore the world on the tip of a cotton swab, what other incredible, invisible worlds are all around us, just waiting for the right menu to be discovered? Makes you think, right? Thanks for joining me on this one.